Hello, mathematician friends. In this video, we're going to start talking about inequalities, which inequalities are things like this: x is greater than 4, because they're not equal, so it compares them. Okay? So starting with the I can statement, I can graph an inequality. Okay, we're just working on putting them on number lines today. So an inequality, there we go. Is a mathematical sentence that compares expressions. So this thing is greater than this other thing. One of them's less than or equal to, right? They're not equal, it's just comparing them to each other. Okay? So this symbol is the less than symbol. Okay? This symbol is the greater than. This one is less than or equal to. When it has this line underneath, that means equal to. So less than or equal to. And this one is greater than or equal to because it has this little line. Okay? And remember that I always learned that if this is an alligator, and you don't have to write this part. So I'll use a different color. So like 3 is less than 4. If I make this into like a little alligator with teeth, he eats the bigger number. Okay, so that can help you. So in this one, it would be 4 is greater than 3, right? Because I make him into an alligator with teeth. He eats the bigger number. So when we graph them and we put them on a number line, we use different types of circles. We don't just put a dot where it goes. You have to use specific types of circles. So we'll come back to this section, but right here, you use an open circle when the value is not included in the solution set. Okay, so these two, since they don't have an equal to part, would not have a closed circle. These would be an open circle. Right, because these don't have an equal to portion, so that number is not going to be part of the answer. It's just where you start your answer. So you use a filled in or a closed circle when the value is included in the solution set. So if it has an equal to part, you're going to use a filled in circle. Like this. Okay, so you're going to use an open circle on your number on the number line if it's just less than or greater than. If there's an equal to component, you will use a filled in circle. Okay. All right, so when you graph them, you first need to determine, should it be an open or a closed circle? Okay, so I'm going to look at the symbol, go back up to my chart, and then decide that. Then I'm going to put the circle on the starting point, so our number. So put the circle on the starting point. Okay, and then you're going to draw an arrow in the direction that makes the inequality true. And I'll show you what that looks like. Okay. So here we have x is greater than 4. So in words, that is x is greater than 4. Okay. It's a greater than symbol, which tells me I need an open circle. Okay. And then we just start with the number it gives us. So we're going to start at 4. So let's start by graphing that. Here's 4. It's going to be an open circle. So you're not going to write your circles really little, otherwise we can't tell. We don't know if you meant to include it or not. Make them a decent size. Okay, not too little, not too big, just right. Okay, and then we draw and shade an arrow in the direction that makes it true. So I'm going to pick a couple of points on my number line to the left and to the right of my number. So here's 4, 5. Okay, so I just labeled my number line. So I'm going to pick a point to the left of my number line. Okay, so let's pick 2. I'm going to say, is 2 greater than 4? No, it's not. So this is not part of the solution. I'm going to pick one to the right. 6. Is 6 greater than 4? Yes. So this is a solution. So I'm going to draw an arrow this way to say that all of these numbers are greater than 4. Okay, so we're drawing an arrow that says anything to the right of my point is going to be greater than 4. So anything going this way till infinity going to be greater than 4. All right, this one, let me scooch it so you can see the whole thing. Okay, x is less than or equal to 7. So we're going to write the inequality. So here's x, and we need a less than or equal to 7. Okay, so all I did was x is less than or equal to 7. Okay. It's a less than or equal to, it has an equal to part, so it's going to be a closed circle. Okay, and we're going to start at 7. So I'm just going to put that on my number line. Do 7, 8, 9, 10, 5, 4. Just label my numbers on my number line. Okay, so we're starting at 7, and it's a closed circle, so I'm going to draw a circle and fill it in. Okay. And then I need to figure out which way is my arrow going to go. So I'm going to pick some test points. Let's pick 4. Is 4 less than or equal to 7? Yes. Okay. What about 9? Is 9 less than or equal to 7? No. So towards the direction of 4 is where we're going to put our arrow. And we filled it in because 7 is part of that. It's equal to it. So I'm going to draw an arrow this way to the left. And notice how I'm shading it in. Okay, you don't want to draw a tiny arrow. You want to be able to tell. Okay? So that is just graphing inequalities. So I'll help you with a couple of these guys. Let's do this one since the number is on the side. So we know we have to start at a -5. Then here's -4, -3, -2, -1, 0, -5, -6, -7, -8, -9, to -10. So I'm going to start at -5. It has an equal to part, so my circle is going to be closed because that -5 is indeed part of the answer. Okay. The -5 is greater than or equal to P. So I'm going to pick a point to be P, a couple test points. Let's do -7 and -1. Okay, so -5 is greater than or equal to -1. Well, it's not, it's less than, so that doesn't work. Let's test -7. -5 is greater than or equal to -7. That is true, so I'm going to shade to the left. Okay. All right, you can ignore these instructions. All right, let's do this one since it has a decimal. So I'm going to start by numbering a number line. I need to have -1.5 on there. So I need to have a 0. This would be -0.5. Here's -1, -1.5, -2, -2.5, -3. So this one's 0. Here's 0.5, 1, and then 1.5. So my circle goes on -1.5, and it stays open because there's not an equal to part. And then I need some test points. So let's test -3 and 0. So -3, is that greater than -1.5? No, remember anything this way actually gets less and less and less. So that is not true. Okay, is 0 greater than -1.5? Yes. Right, because if you think of it like if you're in debt, if I owe someone $3, I have less money than if I just owed $1.50. If I owe $0, I have more money than if I owed $1.50. Okay, so anything towards the 0 direction will be true. Okay. All right, I'm going to help you write this one, and then I'll let you graph it on your own. So a number x is at most 3. So I'm comparing x and 3. At most means that x is the biggest number it can be. Okay? Or sorry, 3 is the biggest number that x can be. So everything else has to be less than that, but it can be 3. So we have an equal to part. Okay? So any number I come up with, the biggest it can be, it has to be less than. The biggest it can be is 3, but it can also equal 3. So x is less than or equal to 3. Okay, so go ahead, try the rest on your own, and good luck.